Alright, welcome back to another video. In this video I'll be covering more differentiation, but now I'll get into the product and quotient rule. But before I dive into the product and quotient rule, let's just do a quick recap. So let's say we have an expression, or let me say a function, f of x equal to x squared plus 2x plus 1. Good. Now if we are asked to differentiate this function, or to derive or find the derivative of, okay, can say, and this is another way to write derivative. So f prime of x, meaning the derivative with respect to x, right, it's 2x, and if we can recall, we multiply by the power, keep the x and reduce the power of the x by 1. 2 minus 1, that's 1, so that's just 2x plus 2, and of course the derivative of a constant is 0. Good. So that would be f prime of x. Now what if we had g of x, and that's equal to, let's say, x cubed plus 2x. Good. And we're asked to differentiate g of x, then g prime of x, assume derivative of g with respect to x would be just equal to 3x squared plus 2. Great. So that's basically what I covered in the last video. Here I just added another way how to denote derivatives. So we can say f prime of x. We get a function f of x, and to find the derivative of f of x, we just write f prime of x. Okay, so now let me get rid of this and dive into product and quotient rule. So for the product rule, as it states, product has to do with multiplication. So if we're asked to differentiate, find the derivative of a product, so that product could be x squared plus 1 times another expression, let's say x cubed. So we can just, for now, let's use general terms so that I can write down the formula for using the product rule. So let's say one part of the product is u and one part is v. We're asked to find the derivative of this product. Now u and v are functions in x, similar to when I wrote f of x and g of x. So we could think of u as being f of x and think of v as being g of x. So now the product rule states that when we have a product, we take the first expression, the first part of the product, which is the u in this case, and multiply it by the derivative of the second term in the product, the second expression, which in this case is v. And as you can see, I'm using the notation v prime. V prime just simply means the derivative of v. So whatever the function is, you would just differentiate that and multiply it by whatever this function is, which is u, right, plus the second term v, the second function v, times the derivative of the first function, or the first expression, right? So this is saying the first, this is one way you could say to remember it, the first times the derivative of the second plus the second times the derivative of the first. So now let's use actual functions. Now let's say we have x squared plus 1 times x cubed plus 2x. Great. Now when we differentiate a product such as this, applying the formula above, our u would be x squared plus 1 and our v would be x cubed plus 2x. So we can say the first times the derivative of the second. So let's write that the first, which is x squared plus 1, put that in bracket, times the derivative of the second, which is v. Now the derivative of v here, and v is x cubed plus 2x, would be 3x squared plus 2. Good. And we have our plus sign, and now it's the second times the derivative of the first. Now the second is v, so we have x cubed plus 2x, put that in brackets, and now we multiply by the derivative of the first. Now the derivative of u, which is x squared plus 1, is simply 2x, and of course derivative of 1 is 0, so that's just 2x. Now we can simplify, well, do not have to simplify. We could simplify the second part by distributing the 2x into across the terms in the brackets, but again we do not have to do that. After we reach here, the question is finished, so you could stop here. But if you want, or if the question specifically says that we should simplify or distribute stuff across the brackets, then you will proceed to do that. But for now, this question is finished, so let's just this is u, and that's v prime, and this is v, and that's u prime. Alright, so that's our first problem. We could do another problem here, d dx of 2x cubed plus 3x, and the other term is negative, let's say negative x squared plus 4x. Good. And so we could identify our u and our v. So that's u, that's v, and just bear in mind that this could be u and that could be v. Doesn't really matter. It's just a matter of convention and a way to remember it. So calling the first term u and the second term v just brings some uniformity and makes it easier to remember. Okay, so now let's go ahead and differentiate. Now, as I said, first, which is u, and our u is 2x cubed plus 3x and our v prime would just be the derivative of this expression. You differentiate negative x squared, you're going to get negative 2x because you multiply by the power, reduce the power by 1, 2 times negative x to the 1, which is negative 2x, and we differentiate that 4x, you just get plus 4. Good. From the formula, you know we have a plus here. Now we're going to have the second times the derivative of the first, so that's x cubed plus 2x great, times the derivative of the first. Now the first is x squared plus, whoa, sorry, I totally mixed up the first question with the second question. You know what, let's get rid of it before it causes any more problems. Good. Now the second term, which is v, that's negative x squared plus 4x. Great. And our u prime would just be six x squared plus 3, and that problem is finished. And that's basically how you do the product rule. Now when we get into differentiating trig functions, the product rules will come up some of the times, and it's the same principle. It's just that some problems you may have trig functions, some problems you may have exponents or logarithms. So that's it. As one of my previous teachers always said, you do one, you do all. So let's just move on to the quotient rule. Okay, and the quotient rule, we use u and v. Okay, let's just write product rule. And now we'll have the quotient rule. Sorry for my bad handwriting. Still not 100% used to writing with this thing. Okay. Now if we're asked to find the derivative, see, I forgot to put the x there. If we're asked to find the derivative of a quotient, meaning one function divided by another function, and again we could think of u as being f of x and g as and v as being g of x. Now the quotient rule states that we have the second, which is v, or in this case the bottom term, so we can say the bottom times the derivative of the top minus the top, which is u, times the derivative of the bottom, all upon v squared. So whatever v is, you would just square v. Okay, so let's apply the quotient rule to a problem. Let's say we're asked to find d dx of x squared plus 2x upon x squared minus 4x. Okay, alright, so how we proceed to do that is by first we identify our u, we identify our v, and we can see that u is equal to x squared plus 2x, and v is equal to x squared minus 4x. Great, so now let's solve the problem. So we have v, and in this case v is x squared minus 4x times the derivative of the numerator, and our numerator is x squared plus 2x, so the derivative of x squared plus 2x, that's just 2x plus 2. Great, and of course we have the minus sign from the formula, and it says u, which is the numerator, minus u times the derivative of the bottom term, which is the denominator, and that's x squared minus 4x. Great. And that's all over the denominator squared, and the denominator is our v, so that's x squared minus 4x all squared. And that's the quotient rule in a nutshell. It's just applying formula. So there's there isn't anything much to the quotient and the product rule. It's just a matter of remembering the formulas. So we could do another problem. Let's see how much time. Okay, I'll do one more problem. Let's clear the screen. Okay, let's say we're asked to find d dx of say 3x cubed minus 2x upon x squared plus 1. Good. Now if you can recall, our u would be 3x cubed minus 2x, and our v would be x squared plus 1, so it's x squared plus 1 times the derivative of the numerator, which would be 6x, 3 times 3, that's 9x squared minus 2. Great, now we have our minus sign, and that would just be now u times v prime. Our u is 3x cubed minus 2x, and our v prime would just be 2x. The derivative of the denominator is 2x, and that's all over the denominator squared, so that's x squared plus 1 all squared. Now that's quite easily done. So that's the product rule and the quotient rule. There isn't much to it. Remember, like, comment, share, subscribe if you're new to the channel, and just practice. That's all that there is to becoming better at math. Just practice a lot of questions, and eventually you will get comfortable with each topic. Now see you in another video.